Welcome everyone. So this will be the second video in the GenAI playlist and it will be helpful for all the beginners to understand the concept and see what all they have to study to get into the GenAI roles, right? So machine learning algorithms. So what algorithms are there by which the system tries to find the pattern in the given data set. So yesterday we discussed, right? I mean in the previous video we discussed how a machine learning algorithm tries to find the pattern and then make the predictions over there. So difference between a traditional code and the machine learning way. So in traditional way, if you take an example, say you need to create from a recipe book, you are creating a cake. So what will you do is you will provide every single step the system has to take, and then the end goal is to create a cake. Suppose you miss or you slightly somehow don't provide one input or one detail, and your end product will be completely different and it will be ruined. In machine learning, what happens is instead of providing steps, you are providing or you show say 10,000 or a huge amount of images of the cake, and the system itself tries to find out the recipe to make that cake, right? So it is sort of finding a pattern in the data to get to the required output. So in machine learning or for the learning of the machines, you have three pillars based on the data that you have, right? That is how they are gaining intelligence. So one is categorized as supervised learning, another is unsupervised learning and reinforcement learning, you can say. Supervised learning, you have regression and classification. Regression is when you are trying to predict a continuous value. When you're trying to predict a value, you can leverage regression model that comes under regression, right? The way you learn it. Then classification is when you are classifying, as the name suggests, right? You have the categories with you and you are trying to figure out to which category this thing belongs to. Similarly, in unsupervised learning, you have clustering, dimension reduction, and associated rule. So we will not go deep into all these algorithms because that will be part of another video if required. This is just to give you an idea how they are working in a general overview so that when you go into GenAI, you're able to understand things over there. So supervised learning. In supervised learning, your data has the output value with you. What does that mean is suppose you have a data for the rainfall, right? Now rainfall is amount of rainfall that happened on that day, correct? So the output or the value that you need to predict or the output is the rainfall that happened. So inputs could vary depending on the inputs that you have. It could be the humidity, the wind direction, the wind speed that is happening, right? Amount of moisture that you have, temperature of that day. So in on all these values, your output depends on, right? Such kind of data is termed under supervised learning, or you say it is supervised learning you can leverage. Under that supervised learning, you have classification and regression. So in classification, what happens is you predict a category. Suppose you want to say that okay, you got an email whether it is a spam or not. So over here you are not giving any value or you're not predicting anything, you just want to classify that email whether it is a spam or it is not a spam. So that such kind of problems will come under classification. Regression is where you are predicting the value. So as we were discussing about the rainfall example, you are predicting that in on this day with these values what could be the rainfall amount of rainfall, right? So such kind of things come under regression. Just for example, to correlate or give you that correlation between maths and machine learning. So think of that we have this data with us where you have age, gender, education level, job title, years of experience, and salary. So in this, we are assuming salary is our output value or the label that we have, right? So, and for simplicity, years of experience, job title, these all are your input values. right? Or you call it feature in machine learning. In maths, this, if we'll say, so this is the how an output or a target output you have and your inputs you have it. So this is a small data set. We have reduced it for better understanding. But in real time or in real world, this will be a huge data set with you, right? To make a salary prediction. Also, what we are assuming is the salary is just dependent on your years of experience. It is not dependent on your job title, education level, which city you are in, what is your previous package or CTC. It is not depending on that. For our understanding, right? For understand the concept, we are assuming the salary is just depends on years of experience. So if a person has 5 years of experience, the salary would be 90,000. If the person has 20 years of experience, the salary is 2 lakhs. It could be month, year, that does not matter. Right now, we have to understand the concept behind it, right? So, years of experience and salary. So, in maths, what will happen is you must be remembering your 10th and 12th standard, right? What will happen is you years of experience and salary, right? So, salary is dependent on years of experience. So, we have x axis where years of experience we have, and then we have a salary that is on y axis. So we'll plot each of these points in a chart, right? So we got these points, as you can see right hand side diagram. You are getting these points. Now what will happen is you will draw a best fit line for these values. So these values are fixed and we know this data. It will not change, right? These are historical data and we create a best fit line. This, the value of this line would be, or how this line will behave is y is equal to mx plus c. So this is the normal straight line, right? In linear algebra, this is the normal straight line equation. So y is equal to mx plus c, where c is your intercept, y is your slope of the line, x is the independent value. Combining all these, you will get the value of y, right? Now y we have, that is the salary component. X we have, that is years of experience. So we need to find out value of M and C. Putting these values in the equation, when we'll solve, so we'll get something on these lines. M would be 67k around and C would be around 41k, right? 6k around will be M and C. Now whenever I put a value of X, I will start getting the value of Y. If over here in the chart also, if I'll see, I put experience of 10, I'll draw the line over here and then I'll get the salary based on it. So now this is how maths is working. In machine learning or in you can say in when you convert it into machine learning, what happens is just the understanding of that thing will change, but the concept will be same. See how? Now in when you are creating or you are using the supervised learning regression algorithm, over there x will be termed as input feature. Feature is on which your value or the output is depending on. So years of experience is one such feature. Another feature could be, say, location, where you will be joining, right? Tier 2, tier 1 city, right? Work from home, depends. Another feature could be what is your last drawn salary, right? On that you will get the new salary, right? So these are the input features on which your output is depending on, right? And in real time, it will not be equal to y is equal to mx plus c. No, salary will not depend only on years of experience. You will have thousands of features on which your salary might depend on, right? So you will have some. So it will be a linear because it is a linear regression. So it will be a linear line. Something like at the bottom you are seeing m1 x1 m2 x2 till n xn plus c. So these x1 x2 till xn, these are your features, different features that you on which your y is depending on, right? C is again the bias. We call it bias in linear maths, or when you will study in that is the intercept what you have, and then M is the weight of that feature. So now what system will do is all this data it will put it in this equation and try to find the value of M1, M2, M3, MX and C. Once it has that value, it will remove this M1 and put that value in. So M1 value, say 3 is there, M2 is 2. Suppose for example, and C is 5, right? It will have that mathematical equation with it, And now whenever I provide the value of x1, x2, x3, right, it will give me a value of y. So this equation what we have is called a model in GenAI, or you call it a model in machine learning. This is just the model how you have adjusted to this linear equation, and then when you have a value you pass it to this model, you use this model, find out the value of y, and the value is returned back to you, right? This is the very simple terms how your maths is getting connected to machine learning. That is why when you see it, go and try to study, right, GenAI or anything, it goes into maths. Why? Because machine learning itself is using your maths. It is not doing anything, it is not understanding your data, it is not finding anything. Just it will find out a pattern, and on that pattern it will give you the output. So this is one such example how maths gets connected to machine learning. So if you go into a machine learning job role, right, this is why the maths is very important. That is why when you will see sometimes there is a requirement of mathematical, statistical learning, linear. So you require linear algebra, you require calculus, you require probability. These things and stats. Stats are mean, median, mode, average, max, min, those kind of things. And how do you implement it using the programming language? So now if you do this part manually before computers, you would have been able to do this manually. But now if I increase the features, right, to say 100 features are there or 100 columns you are having, right, or I can create few new columns also combining 2 3 features into one, right, I can create a new column if I think that so if I have a long equation it will be very difficult to resolve it manually, but whereas for computers it will be very easy for it, right? So that is why you are performing the same task or that concept using your programming skills on your computer. That is why you see if you are creating so many or if you are basing your output on so many input feature, right, so that it becomes accurate, you require a lot of data set over here, right? This is very less data points, and the best fit line which you are seeing over here, the red line which you are seeing, might be correct, might not be correct, right? In most of the cases might not be correct, right? So if you have huge amount of data, it will be easier, right? So moving ahead, classification. So what happens is, again, now you are classifying your data into groups, right? So this blue circles you are seeing, red triangle rectangles you are seeing, then pentagons you are seeing, right, violet pentagons, yellow squares, so they are grouping of data together. So what happens is you have labeled your data is labeled. In supervised learning your data will always be labeled. That means you will have an output value. So accordingly you have bifurcated or you have grouped them into one group over here, and now you use that classification to provide you output. How can you use it? Say you have grouped your data on the training set, and the data which you are providing, the historical data or data which you have, that is called a training data set. Training in the sense you are creating that mathematical equation for you. That is the training of the data. So you have, say you have the two separate classification, one is plant and one is animals. You have provided the image to it, and you have, you those images were that this is a plant image and this is an animal image. Now that segregation or mathematical equation has been formed. Now we provide a new input in which there are two animals and one plant. So what it will do is it will be able to predict, if you have trained it well, if that mathematical equation is very much correct, right, it will be able to classify this. Okay, this is a plant, this is an animal, this is an animal, right? So different classification algorithms we have, and all these are your mathematical equations only. You solve it in maths. K means, hierarchical, Gaussian measurement model, they are all depending on maths that you have. So for GenAI for beginners, you do not go into these many details. These are just for your reference purpose, because these videos which we are creating, I will act as an index for you. So you will have these idea or you will remember these words with you. Once you start going into deeper, right, when you start going into maths, then these You can understand how they are working in maths, and then you can learn how to get it implemented using any programming language. Now, unsupervised learning. So in supervised learning, what happens is you had your data labeled. Now there might be condition where you are not able to label your data. So one way is that you have your data, now you label it. So now labeling it will be a difficult task, because you will have billions and billions of records. So you will require compute resources, your memory, your CPUs, your manpower to label it. So there is another set of algorithm which we term it as unsupervised learning, where you do not label your data, you just provide your data to the system, and the system will create the clusters for that. It will label it, right? Unlabeled data, it will cluster it. This is a similar kind of data, this is a similar kind of data. That is how it learns the pattern. So where this unsupervised learning could be applicable is, say you have news section, right? Google News you are having. So you want to segregate it, or you want to make sure that the articles are categorized into the same story. So now these are not labeled, and the news which you will get, they will be, I mean, if you go around the world, there will be a lot of news for that day. You're not able to label it, right? So you will use something, some algorithm that are comes under unsupervised learning, and then system itself will be able to provide you the category of that. Another way, implementation could be computer vision, right? You have your camera where it is trying to recognize the objects. Now you might have trained in that system on some object, there might be some object which are new for it, right? So the system should be well conversant to create that separate labeling for them. And then you will leverage something called unsupervised learning algorithm. Or it could be a medical imaging. So say you are going in for an x-ray where you are trying to find out if bone is broken or not, or if there is a, say, a cancer patient is there or not, right? So that image could be different. It could be that the data set on which you trained, it had that image. It could be that it didn't had that image. So the system now needs to see whether that image which you have sent, the x-ray image, whether that constitute an x-ray, I mean constitute a cancer or not, or it is not a cancer, right? In such cases, you use unsupervised learning. You have other ways also to do that, but the core concept is unsupervised learning. Now, what is reinforced learning? Reinforced learning is where the system is running, and according to the decision what it take, whether it was a good decision or it was a bad decision. If it was a good decision, you will the system will be rewarded. If it is a bad decision, the system will be penalized. For example, you might have went to a circus or something, right? You have a lion where it is asked to sit, right? That is how the ringmaster or the circus master trains the lion. It will ask the lion to perform the certain task. If lion is able to perform it, it will be rewarded. If it is not able to perform, it will be penalized. Think of that lion as an reinforcement learning. That is how reinforcement learning works. Very pure example from your daily life. Think of lion as an machine learning algorithm or a system or an agent, anything you name it. It is that agent which you are asking to do some task. According to its learning, it will perform that task. If the task, say you have asked the lion to walk, if lion understands your command and it walks, that means it has to be rewarded. Similarly, you will ask your algorithm to perform some task for you. If the algorithm performs the task very accurately, you will reward it. Otherwise, you will penalize. Basically, it can be points, it can be stars, anything for the system. So those kind of ways or those kind of methods comes under reinforcement learning. Now, how this leads to your generative AI, right? Because we are focusing on generative AI. So all this discussion, how it boils down to your generative AI. So earlier you used to predict something. Now generative AI, as we discussed, it is creating something for you. So how you are leveraging it. Say you have all your labeled data and then you are guessing the patterns. Is it a cat? Will it rain or not? Right? Those kind of predictions you are doing. In generative AI, how will you be leveraging the same concept is draw a cat or draw a blue cat for you. So it will use the same concept. It has to understand what is the cat, then it has to understand what is a blue color, then it will create an image for you. So it should know how to create an image, right? So that is how it is generating things for you. Same concept is getting applied but in a generative AI format. Say write a poem on a rainy day, right? So now it has to understand what is rain, it has to understand what is poem, it has to understand how to write it out. So same algorithms you are using in your generative AI also. The models which are there, that is how you are getting implemented at the backend. So auto completion. So tools like chat gpt and all, right, they have been trained on huge amount of internet data. Now all that data is not labeled, you cannot label everything. There are billions, I mean petabytes of data that is there on we trained on, and you cannot label everything. So that is why it is using a unsupervised or supervised learning for it. So later that is labeled, it uses that, then unsupervised also it uses to train itself, right? So combining all those is how you are scaling your modern AI now. So unsupervised learning, because it is been trained on massive amount of data. Now there might be some requirement where you need to fine tune it, right? So fine tuning, we'll see in the later concept how what is fine tuning is, but you fine tuning is done on the supervised data because it is a less amount of data and you can put a label to it. And then you might have seen when you are using these models, then reinforcement learning is using it. Why? How? Because whenever you ask some question or you provide some task, if it completes, in the end it asks you whether it fulfilled your requirement or not. According to your input, the system will try to learn. Say you say that yeah, you fulfilled correctly, so it will understand that okay, this is how this user tries to perform the task. It will try to understand your behavior, right? It will try to understand you. If it didn't perform it well, then you will tell that okay, this part was not performed well. It will understand you. So all those kind of algorithm or all those learnings that we saw, right, those three pillars, it is using all those three pillars to enhance itself, right? So this is all for today. How GenAI, maths, and don't worry about the maths if you're going for GenAI or if you're starting the GenAI journey. Though these are the words that you should know. You should know what the model is. Model is the mathematical implementation or the equation that you have created. That is the model. So if you see the size of the model, it is very less. It is not huge. But the training data or the data that you have provided, that is very huge. So that is why, and you need to process it, right? You need to find out the mathematically, you need to find out those weights, right? Those things you need to find out. So you need your computational power. That is why GPUs, TPUs, you are seeing those things. Keep these things in mind, and whenever you are trying to go deeper into it, you will tend to remember these things in your. So that's all for today. I hope you enjoyed it. So please do like, share, or subscribe the channel, and we'll connect again. Thank you.